Okay, so hey, welcome everybody. Hi, my name is Christy, and I am a dev advocate at a company called Zilliz. We are the company of maintainers behind open source vector database Milvus, and I recognize some familiar faces here from our events that we hold here called Unstructured Data. So normally my format is I like to go through some slides of theory and give people a background and then do a demo. But tonight, because it's multimodal, I'm assuming this is very intuitive for people. So we decided to reverse the order and do the demo first, and then Ash, who really gets all the credit, is going to speak about the theory and some slides. And Ash had told me he had some hairy assembly language to debug for a client, so that's why he's not here in person. But we're still happy. So I am very bullish these days about small embedding models. It might sound counterintuitive. If anybody was here for one of my events where the speaker from OpenAI was here, Yuri Malkov, he spoke about Matryoshka embeddings, and it was one of the ideas behind the new OpenAI embeddings, where you can get practically the same accuracy from embeddings that are 512 or 256 dimensions, or even bigger and smaller dimensions. And the thing is that you really don't need sometimes such large embeddings. So I'm I was very intrigued by all this, and I wanted to try out this UForm. I guess we can close that. I don't want to close I can close Zoom, I guess. Okay, yeah, so this is the GitHub. It's open source. I have a very small laptop. I only have 16 gigabytes of RAM. So I'm going to be running these embedding models inference mode locally on this laptop. So yeah, you can check out this GitHub. It's called Unim, UForm, and there's these different embedding models. I'm going to be using this multilingual, which supports 21 different languages. And Ash is going to show the benchmarks for that later. It's really impressive. And you can also check out, they're all on Hugging Face. So if you've used Hugging Face before, nothing new, no new syntax to learn. So let me get to it. All right, so here's a quick demo. First thing we do is download some images, and you can just download these directly from his datasets page, which is what I did. That's the easiest and fastest way. You get 25,000 images, which is really nice. And I can run this live. It just takes a few minutes to do the embeddings live. So I'm just going to show you that I download it, and I keep a list of the URLs and the text. And then I'm going to create a Milvus collection. So beginning this week, we have a new product announcement called Milvus Lite, where you can run Milvus locally with only 2 lines of code. Unfortunately, the developers told me that the hybrid search is not supported until 2 more weeks. So tonight, I'm still showing the old-fashioned Docker. Yeah, in 2 weeks, you'll be able to run this in 2 lines, pip install PyMilvus, and client equals PyMilvus. But for now, I'm going to run a local Docker. So connect to the Docker and print my PyMilvus and Milvus server version, making sure that I got 2.4 in both sides. Then I'm going to set my embedding dimension, which is only 256. Going to create a schema. So my database is going to have a primary key ID. It's going to have a text vector and an image vector. It's going to have the actual chunk, and it's going to have the actual image URL to it, at least. I don't need to double store those. And I'm going to call it a name, demo multimodal. And then I just create this collection with that schema. And then this is another important thing, that I need to create the hybrid index. So I create an index for the images with a metric type cosine, and also one for the text with cosine. Okay, so created the collection. Then I'm going to define my embedding model So I'm using the Onyx UForm torch, and Ash is going to explain some more about that later. So basically, you just have to pip install those, and just in Hugging Face fashion, define your model name, and then declare your model with that model name. And then I'm going to do very small batch sizes because I have very small memory. If you have a bigger machine, maybe you can run bigger batch sizes. So in this demo, I only ran it up to 600 images just because I wanted it to be fast, which means my results aren't going to be so great as if I had run this for more images. If in case people are interested, there's also this like kind of helper functions are back here. So this is the way I defined the class for the compute embeddings. So it's just got an init to initialize the models and the processors. And then it's got a callable method for the inference of the embeddings themselves. So I do whether I'm embedding an image or whether I'm embedding a text. So that's what's being called here inside this loop of batching embeddings. So I ran that. And then I put it into like a list of dictionaries because I'm going to go ahead and insert that. And this is the insert statement for inserting the data one batch at a time into the vector database. And then after everything's done, you flush the database. So here you can see I did this in 10 batches of 10, and there were just a couple image errors. So yeah, and then I also want to keep track of just the metadata that I have. I have the ID chunk and image file path because I'm going to use that later in my search. Okay, so now we're ready for search. I run this count rows. Okay, now I can run live. Yeah, so we got 598. So we missed the 2 images that had errors. I'm going to try out some questions, and I just tried. I tried them in French and different languages, and grabbed some fun images about Rocky Mountains at sunset. And so I can ask it in Arabic, and I can get images, text to image query. I can do a reverse image search where I put in this image on the left, this cat, and I call the hybrid search of Milvus, and I can get back cats. And this I know would look nicer in Voxel 51 because they have a really nice image navigation tool. So I get back some cute pictures of images of cats, and then I could. Oh, here's where I put my Arabic. Okay, I forgot. All right, so here's where I could have a question, Rocky Mountains at the golden hour, and I could have it in French, Hindi, or Arabic, for example. And so right now it's set at Arabic. That was my last choice. Okay, phew, I wasn't losing my mind. Okay, so I might just ask, both a question and a picture. And in that case, I'm going to ask both the question and the picture, and I'm going to get, more images. Okay, so yeah, that's just to demonstrate how easy it is to use these pocket embeddings that are running locally on my laptop. I recommend you check this out because, yeah, who needs a GPU? Embedding models are getting smaller and smaller, so it's really fun to check them out. Now for the generation part, I'm just going to give a quick demo using GPT-4o. Because this demo is not about demoing GPT-4o, but I just want to close the loop with the G part of generate RAG. Okay, so I set my model parameters. I create a prompt, write a travel blog, put these images that I give you in line in my blog. I'll put the blog post in Hindi, and also output the blog post in an HTML format, so I get a web page out of it. So the kind of the line of thinking for my demo here is that maybe I wanted to search my images for a nice mountain picture of my hike, and maybe I wanted to search for a cute picture of my cat, and I have many pictures of my cat supposedly that I wanted to search through. So now that I've picked out the best picture of this particular hike and this particular, and my particular cat, now I can feed them to a generation, a multimodal generation, and say, write a blog for me about this. So this is the basic OpenAI, which you've probably seen many times. Here's my LLM name is GPT-4o, and I use my API key, and I give the system the prompt and the question, and I get back, just run it live, just so you can see. I get back HTML, and then I can copy this HTML and paste it, into extra, and then save it, and then I can go into here. Yay, I've got a web page. And I can translate if I wanted to. Maybe I want to translate that back to English just to see trekking with my cat. Yay.